All right, thank you. Good morning. I see everyone is here, excited, energetic, right? Yeah, we need some caffeine. So hopefully you get your caffeine. If you haven't, at 10 o'clock you can get your caffeine. So I'd like to talk about the systems that are available today. So for Project Olympus. So a year ago we announced Project Olympus. It was about half done, right? We said, hey, we're bringing this to the community. We want the community to engage, to give us feedback so that we can get better systems. And what we found was that people and companies started really jumping on and started contributing more and more items to this. And so, the first systems are actually available. They're shipping. If you want to use them, you can go to Azure and sign up and get an Azure VM and actually run on an Olympus system. But you can also purchase them for sale, or you purchase them for your own use. But there's a whole lot more that's going on in the industry. So when we look at to give you an overview, when we look at the system, really Project Olympus is an overall rack level system. We have an AC distribution in the back. We have a standard 600 millimeter wide, 1200 millimeter deep rack. It is a 19 inch, but does that really matter? We think it does. We think that the 19 inches, at least this form factor, is very, very compelling. We have AC distribution in the rack. So we actually distribute dual AC power feeds, 3-phase, for balancing to increase the number of servers that you can have in your data center and reduce your overall costs. In that distribution, we also have a little management controller that we use to manage the entire rack. And so that's our point of entry for everything. It's for, you want to talk to the servers, want to talk to console and that sort of thing, you go in through the rack management. If you want to get event logs, diagnose anything, find out what's going on with the machines, you go in through the rack management. That's the way that we use it. When we created this power distribution, we also created what we call a FireWire universal power connector. So on one end there's a connector that connects into the PDU, and it's a special connector. You can see it out on the floor. On the other end, you can put whatever power cord you need, and you can adapt to it. And so what we've done is we said that's so useful, we've created a universal PDU. It's a 2U PDU with the same connector. You can build any PDU you want with this connector. And for us, what's important is that you build the rack once, you never change the PDU, you go to a different data center, you just put in the power cord you need. So we have airflow blockers. So this is when you look at the structure here, we have these little side rails or slides for the servers, and this airflow blocker works such that it snaps in with the slides. And if you don't have the slides, you flip it over and it snaps into the regular rack. These are contributions, these are contributions that are all accepted today by OCP. We contributed over 20 specifications and pieces of collateral and that sort of thing to OCP this last year. In fact, we overwhelmed OCP so much that they said, let's take let's make the votes in batches. So we've gone through 2 batches of votes. We still have a 3rd batch to go. And so, there's still some that are contributed but not yet accepted. And so what I'm showing you here is all the accepted presentations. So when it comes to servers, we have a standard server chassis, and we actually have two motherboards. But the one that's accepted today is the Intel Xeon scalable processor motherboard, otherwise known as Skylake. And so that's fully contributed. All of the collateral, mechanical, electrical collateral is actually out there on the OCP website now. We have 2 different versions of the chassis. One's a 1U, that's a standard regular server. And then we have a 2U, which is, which has 12 hard drives in the top U. And so that's kind of a, like a medium-sized storage server, before you want to go to a big JBOD. Those are all also contributed, all the CAD files and everything. So everything, when we contributed our 20 items, not everything is all collateral. Parts of these are from the ecosystem. And so we did contribute the universal motherboard specification. That's the basic, you build a motherboard, it's this big, it has I/O slots in these positions, it's got mounting holes, just right where they need to be, that sort of thing. And anyone can build a motherboard to it. So that's what our Intel motherboard conforms to. But we also have an AMD EPYC motherboard specification that we contributed and was accepted. Quanta has actually contributed the full AMD design to OCP. We haven't voted on it yet, but it's out there. I'm sure we'll get it accepted soon. There's also a Cavium Thunder X2 specification that we've contributed as well. Oops. Okay, now talking about things, these are the items that were contributed but haven't yet been accepted just because we needed 3 batches of votes. So the rack, and a lot of people ask about the rack. Hey, are you contributing all the CAD files and everything to the rack? It's like, actually not. The rack, this is part of an ecosystem design, right? And so the rack was, for the most part, with a few tweaks, an off-the-shelf offering that we worked with Rital on. We have a 42U and a 48U. We chose just those 2 heights because we wanted a taller for more capacity and a shorter for those data centers that can't handle the height. But we didn't want to go too tall because you go too tall and then you have transportation issues. You need special trucks and that sort of thing. And so 48U keeps you just inside this regular truck and all that. But so we're contributing the specification for the rack, but if you want to build your own, you have to build it off the specification. The rack manager, we contributed that specification. I'm actually off trying to gather the collateral so that we can actually contribute that now. But to date, we've only given the spec. And so we have the rack manager that goes into the PMDU. I guess, is this a... So this is the back in the power distribution unit. This is the rack manager. But what we have here is a standalone rack manager. And so if you have equipment that's not like Project Olympus, it can still be Project Olympus, right? Project Olympus doesn't necessarily mean that you have to have exactly our infrastructure. It's for at least for Microsoft, what's really important is that the interfaces to the data center are standardized and consistent. And so we can take this same rack manager that we put into our infrastructure, we put it into a 1U 19-inch rack compatible box, and it can plug into any rack, right? I mean, we can take that and we can take the management switch, put that into any rack, and then we can hook it up to anybody's equipment. So your equipment just needs to speak our interface. And that's what's really important, is that all the automated tools that work in the data center can talk to your equipment. And so this is our path to allow all of that equipment that is not standardized, it's not OCP, this is our path to get everybody else's equipment at least in through our normal data center interfaces. And of course, I talked about the power. We contributed the universal power cord. You why is a power cord, why is that a big deal? And I used to think that's not really that big a deal, right? Until I discovered what it takes to actually get a power cord into production. So this universal power cord, you know, you've got the 5-wire interface that goes to the Project Olympus power distribution unit and also to the universal PDU. But you have that standard 5-wire interface, but then you have any other, you know, standardized cords on the other end. So we have, you know, your normal 3-phase 50 amp, the 3-phase, that's the 4-wire. Then we have the 5-wire, you know, 400, 415 volts for Europe and other parts of North America. We even have a 3-phase 30 amp power cord because we found, oh, hey, a bunch of our labs and some of our countries take 30 amps. We may even have a single-phase power cord out there that we're working on. But it turns out that every single power cord needs and requires its own certification. Even if you just change the length of the cord, it requires going through the whole certification process, you know, UL or whatever these agencies are. And so that turned out to be a much bigger deal than what we thought. So the power supply is another example of an ecosystem developed item. So we've worked closely with 2 vendors to build power supplies, but we've contributed the specification. But you know, when you go to buy an Olympus server, of course it comes with the power supply, right? But you could, if you wanted to, just go directly to the companies and buy those power supplies themselves. And then we've got a number of expansion chassis that we're working on with partners there. So, you know, we have the 88 hard drive, JBOD, that's the DX88. We've contributed that specification. What you'll see is that, you know, Quanta is contributing, or Quanta is delivering this, enabling it for purchase. It's not quite done yet. As well as, you know, it takes a unique power supply. So there's a power supply that goes in there. So we've contributed the specification. And, you know, what we showed last year and we have out on the floor, the HGX1 hyperscale graphics accelerator chassis that takes the NVIDIA GPUs. So I think all of this equipment we have out on the lab or out on the floor. And the thing about Olympus that's great is that the ecosystem keeps coming in with more ideas, more things that we can do to you know, to build and improve our servers. So of course the first, I hope you heard the keynote yesterday talking about Project Cerberus. It's a new security, you know, working to secure your servers, you know, keep the firmware all the way through the entire supply chain, so that nobody can, you know, get to your data in the supply chain, but then in operations as well. You need to keep everything secure. And I think, you know, maybe one of the probably more important functions is, yeah, you may have people security issues here or there, right? But it'll also help you from accidentally downloading the wrong firmware and stuff. And, you know, it's like, well, this is the wrong firmware, and it'll, you know, it's not signed and that sort of thing, so it won't match. So, you know, there's definite operational aspects to that. So Cerberus today, you know, we're you know, there's a whole new security group on that. We're working on it. We're prototyping it in a couple of systems right now. But what we intend is Cerberus is not, you know, right now we show this little card, right? But it's not just that card. It's really the whole you know, it's really the whole system around it. What you really need is hard drives that have signed firmware, you know, flash drives that have signed firmware. Anything that has firmware needs to be signed. You know, anything that can have its firmware updated, you know, needs to be part of this. So you need to make sure that you have the firmware that you intend to have on your systems. So another big thing announced yesterday was Project Denali. So this is open channel flash. It's high density storage. How do you, through your applications, get better control, get better performance, get better reliability and features out of your flash devices? And that's what Project Denali is all about. And you'll hear more about that later this morning. And the FX16. This is a project that's under development. You can see one out in the out on the shop floor, the expo hall floor. And what this does is it allows 16 EDSF compatible flash devices. I've got two versions here. Okay, the first version is a carrier with 4 M.2s on it. And this allows us to take the same flash that we're using inside of our servers and put it inside this expansion box. But EDSFF is actually defining different form factors, right? One of the form factors is a long form factor, and so Intel has what they call a ruler specification, but it's all EDSFF compatible, right? So look at these; they look almost identical, but they're just different technology underneath. And so this is another example of how we're working through the ecosystem, through the industry, so that we can use, get more of different vendors' technology into our systems. Another thing that's become a huge focus over the past few years is machine learning. So last year we announced the HGX1 hyperscale graphics computing system with the NVIDIA SXM2 module GPUs. This year we're showing that we're underway, and this one probably isn't even 50% done yet, so there's no specification. It may be 10 or 20% done. I don't know quite where it is. But it's an example of a 3U chassis that is fully Olympus compatible. You just plug it in and it mates into our AC power distribution unit, uses all of our management. And it's a new chassis, but it's also based on our motherboard. So you have our motherboard, it's got 3x16 slots, you plug in 3 risers, and each of those risers is capable of expanding to 4 expansion slots. So when you put that together, you could put actually 6 GPUs into this box, 4 or 6, or you could put 12, standard width, full height into the chassis. And so that's going to be flexible. Very flexible offering for us, but it's really targeting all of this AI and machine learning applications. And when we think about the ecosystem, this is probably not a complete list, but it's quite large. So we have CPUs, we have Intel. Intel's the first server that we had. Then there's AMD, there's Qualcomm, Cavium, NVIDIA for graphics processing, and then a whole lot of companies in the components. And then in the solutions, if you want to actually purchase these systems, both WeWin and ZT have these available on their websites today for purchase. These are just some links. So for the Project Olympus part of today, I wanted to say that the next presentation, Quanta will be talking about their contributions to OCP at 9:30, and then the expansion chassis, both the flash, the GPUs, will be covered at 10 o'clock. And then at 10:30, we'll have Project Denali with the high density storage. So, okay. Do we have time for questions?
5 minutes. Question.
5 minutes? Any questions? Anybody? Somebody's got to want to know something. You all saw the top 10 questions, right? What's the difference between what?
The two rulers.
Between the two rulers. Yes, good question. What's the difference between the two rulers? This ruler accepts M.2 modules, 4 M.2 modules. This one is a monolithic PCB with a controller and flash on the PCB. Did I call them both rulers? I don't know. They're
In
both
other words,
EDSF.
the first one is not a ruler.
Yeah.
It's a EDSFF form factor based on which you guys can contribute whatever you like.
So
Basically-
EDSFF is the industry group that defines, what's an SSD, what's the form factor, what's, U.2s, M.2s. They define all of those.
Think of it as a new PCIe form factor. There's a by 8 come in, and it has that shape.
Yeah.
So on the monolithic PCB form factor, what capacity is that available in?
I don't know.
18
18 millimeter? No, that's not.
It's just there's going to be a little bit more detailed discussion on it. The capacity is based on the number of NAND devices you can land on it, and it's up to the community to build whatever you guys like.
Yeah.
Then what about other form factors rather than EDSFF? Is there any plan to adopt any other form factors?
Well, what we're working on is EDSFF here. We use M.2 inside of our servers, and we have expansion slots that you can plug in full height, full length inside of the servers. There are potentially, this is a very nice space. As CMAX says, you have a by 8 connector at the back. You have airflow going through. You have power. You could, community could probably build anything that can fit in this space and can be cooled. They could build it. This is what we're working on.
It doesn't have to be storage. It's a PCIe form factor.
Switching to the rack, is there a weight limit for the 42U rack?
Yeah, so we do, I think our data centers are 3,300 pounds. And so the rack is either 3,300, it might be a 3,500 pound rack. It's part of the spec. Yeah, it's part of the spec. Yeah. Alvin, yeah, he's at the back. So let's get the next presenter. We can keep with questions while we set these up.
Let's get questions still coming.